Okay, so now we're going to put all this stuff together we just talked about. So we can start graphing polynomial functions. Okay, so I have some steps for you for graphing polynomial functions on your green handout. Okay, so we have our polynomial function. Step 1 is we're going to find end behavior, and the way we're going to do that is by our leading coefficient test. Okay, that was one of the very first things we just talked about in this lesson. Step 2 is we're going to find our intercepts, our zeros, whatever you want to call them, and their multiplicities, and determine what the graph is doing there, touching or crossing the x-axis. Step 3, we're going to find our y-intercept. Okay? Step 4 and 5 are really just checks to make sure your graph is reasonable. Okay? So step 4, you use symmetry to look at your graph and make sure that makes sense what you have. And then step 5, you look at your turning points and make sure that you're not exceeding the number of turning points we said that you could have. Remember, the max number of turning points was 1 less than your degree. Okay, so let's do an example. So f of x equals x to the 4th minus 2x squared plus 1. So what was step 1 on your green sheet if you need to look? Step 1 was use the leading coefficient test to determine end behavior. So remember, to find end behavior, we're going to look at the leading term. Okay? What's the leading term? Okay, remember, your leading term is your term with the biggest exponent on your x. Okay? So where's the biggest exponent on one of my x's? Well, it's this 4, okay? So my leading term is this whole piece right here, which is just x to the 4th. Now, there are two things I look at to determine end behavior. What's the first thing I look at? First thing I look at is whether or not my number out front is positive or negative. Well, there's not a number out front, so if it's not a number, it's just a 1. Right? And is 1 going to be positive or negative? Well, it's positive. So this tells me what my function is doing to the right. Okay? So we can think about just a regular quadratic function. Okay? So if you just have a positive number out in front of your quadratic function, what's that going to be doing to the right? Well, it's going to be going up to the right. The other thing we look at is the what? We look at the exponent. And what do we look at for the exponent? We look to see whether the exponent is what or what? We look to see if it's even or odd. So is 4 even or odd? 4 is even. So what does even mean about my end behavior? Well, remember, odd means opposite. They both start with O's, so odd means opposite, so even must be the same. So even means that my sides are doing the same thing. So if my right's going up, and they're going to do the same thing, that means my left must also be going up. So there's my end behavior. Step 2 is to what? Step 2 is to find your x-intercepts or your zeros. Okay, so we find our x-intercepts or our zeros by setting our function equal to 0. So 0 equals x to the 4th minus 2x squared plus 1. So how do you think we're going to solve this? Well, if you said AC factoring, you would be correct. And if you didn't say AC factoring, it's probably because this problem looks a little confusing because you've got this x to the 4th instead of an x squared right in the front. So the way we can make that look a little bit better is by using a substitution. Remember, I think we've talked about that. So if you want to make a substitution, you can say some other variable equals x squared. M equals x squared. Now looking back at what I have, well, then I can take my negative 2x squared and replace that with minus 2m plus 1. Okay? So if m equals x squared, then we square both sides. M squared would be x to the what? X to the fourth. Okay, so that means this x to the fourth can actually be written as an m squared. Now we can use AC factoring. So make my table. A times C is what here? Well, A is 1, C is 1, 1 times 1 is 1, B is negative 2. So what multiplies to positive 1 but adds to negative 2? Okay, so negative 1 times negative 1 is positive 1, and negative 1 plus negative 1 is negative 2. So my factors I'm looking for are negative 1 and negative 1. Negative 1m, sorry. So we replace that with negative 1m, negative 1m. And now we have 4 terms, so 4 terms we factor by grouping. So group the first 2 together, group the second 2 together. GCF of my first is m, factor out an m, leaves m minus 1. GCF of my second is just a 1, but because I have a minus on my first term, I need to factor out a minus 1, and that leaves m minus 1. Continuing factoring, we get m minus 1 times m minus 1. Now, we can't just keep going like this because I didn't start off with any m's in my problem. M was something that I added in to make myself feel better about what I was dealing with, okay? So I have to change my m back to what m stands for. And what does m stand for? M stands for x squared. So change it back. Now, what do you notice about x squared minus 1? What kind of factoring is x squared minus 1? If you said difference of 2 squares, you get a gold sticker because it is a difference of 2 squares. So x squared minus 1 right here is going to factor to x minus 1 times x plus 1. Same thing over here, x squared minus 1 is going to factor to x minus 1 times x plus 1. And let's clean this up a little bit. How many x minus 1's do I have? 1 here, 2. And how many x plus 1's do I have? 2, so x plus 1 squared. Now this is all factored nice and neat for me, okay? So don't get yourself bogged down in the factoring. Go back and what did we write at the top? Zeros. We're finding our zeros, okay? So to find our zeros, we next set each factor equal to 0. So that's x minus 1 equal to 0 and x plus 1 equal to 0. Solve these, we get x equals 1 and x equals negative 1. What's my multiplicity of x equals 1? How many times do I get x equals 1? Well, how many times did I have this factor x minus 1? I had it twice. So my multiplicity is 2, multiplicity of 2. And what's important about the multiplicity? We look at whether it's what or what. We look at whether it's even or odd. Is 2 even or odd? 2 is even, so even multiplicities do what to my x-axis? Even multiplicities touch my x-axis. Now over here at x equals negative 1. What's my multiplicity of x equals negative 1? How many times would I get it? How many times would I get x plus 1? Well, I had x plus 1 twice, so that means I have a multiplicity of 2 here as well, which again is even. So even multiplicity does what? Touches the x-axis. Okay, this brings us to step 3. Step 3 is to find your y-intercept. How do we find a y-intercept? By setting x equal to 0. So I can't get my whole function on the page, but you can look back in your notes. Here's my function. I'm going to plug 0 in for all my x's. So f of 0 equals 0 to the 4th minus 2 times 0 squared plus 1. That equals 0 to the 4th is 0. 2 minus 0 squared is just going to be 0. Plus 1, so equals 1. But how do I write a y-intercept? What's it got to look like? Remember, a y-intercept is a point, so it's got to be an ordered pair. So what's my x value? Well, my x is 0. My y value is 1. So there's my y-intercept. Okay, so let's start putting a graph together from this information we have. I hope that's enough room. Okay, so it's always nice to start with things you know that are solid. We start with the points, okay? I know exactly where the points go. Okay, so there are 3 points we have here. We have our zeros. Okay, remember our zeros are just another name for our x-intercepts. Okay, so we actually found x-intercepts. So we have an x-intercept of x equals 1 and an x-intercept of x equals negative 1. We also have our y-intercept, which is the point 0, 1, so right here. Okay, so once I have my points on there, let's go to something else that's also pretty solid, and that's my end behavior. Okay, so looking at this right x-intercept over here, this is the last point that my graph touches the x-axis, does any sort of touching or crossing to my x-axis. So from here on out, it's got to go one direction, okay? It has to go one direction. It never turns and comes back the other way because it doesn't ever hit my axis again, okay? So based off my end behavior, way up here, I said that towards the right it was going up, okay? So from here on out, it's got to go one direction, and that direction is up based off my end behavior. Okay, same idea on this left side. Okay, this left point is the last point where it touches or crosses or anything to the x-axis. So out this direction, it can only be going one direction, and based off of my end behavior, I know it's up. Okay. Now this is where knowing our multiplicity information comes into play. So we said that the multiplicity, we'll start with x equals negative 1. Multiplicity of x equals negative 1 was 2. Okay, 2 is even, so that means it's going to touch and turn. Okay, so it touches and turns. So since my end behavior is going this way, and it touches and turns, I know it's going to touch here and turn back the same way. Okay? Now, looking at where my y-intercept is, I can see it's going to go run into my y-intercept, right? Now, for over on this intercept, okay, this is x equals 1. The multiplicity here was also 2, which was even, so we said it also touched. So it's going to turn and go back in that same direction. and it also is going to meet up with that y-intercept. And there's your graph. Okay, steps 4 and 5 are checks for you to kind of make sure it makes sense. Okay, you can look for symmetry. You can plug in negative x to see what kind of symmetry it has, and you can look at the max number of turning points. Okay, so based off of turning points for this problem, what is my degree of my function? Well, the degree is 4. Okay. So my max turning points are what? It's 3. It's 1 less than 4, so it's 3. And so we can just go in and check and make sure I don't have more than 3 turning points. And you can see I have 1, 2, 3. So that's good. Okay, let's do another example of a graph. Okay, so step 1, you remember, was to find the leading term. So this is that same weirder type of problem that we had earlier when we were talking about end behavior and leading terms, where my function isn't all multiplied out, it's still being multiplied together. So remember, the way to find the leading term is to take your function, write it out, so write your exponent out, x minus 1 times x minus 1 times x plus 2, write out your exponents, and then you're looking for the biggest term with the biggest exponent. So you take all the things that are being multiplied together and multiply the biggest thing, the biggest exponent, whatever you have that's biggest in that piece you're multiplying. So the things being multiplied together here are negative 2, x minus 1, x minus 1, and x plus 2. So I'm looking for the biggest thing being multiplied in each of these pieces. So negative 2, well, that's the only thing there is the negative 2. I don't have any other options but to use the negative 2. So we use the negative 2. Now x minus 1, I have a choice. I have an x or I have minus 1. Well, what's bigger for an exponent on an x? Well, it's going to be the x. So we use the x. Same thing, I'm looking for the thing with the biggest x. So I choose the x here, and I choose the x here. Multiplying those all together, that gets me negative 2x cubed. And that's my leading term. Now there are two things we look for on this leading term. So first we look at the front. So my front is negative. So that tells me what it's doing on the right. So remember, think about a quadratic function that's negative. What's it doing on the right? What's going down? Then we look at our exponent. My exponent is even or odd? It's odd. Odd means opposite. So my ends are doing opposite things. So my left side must be going up. Next, we find our zeros. You find your zeros by setting your function. Again, it's off the page, I'm sorry. Oh, there it is. Setting your function equal to 0 squared. So I went back to the x minus 1 squared because it's a little bit quicker. Because I set all of my all of my factors with x's in them equal to 0. So that's x minus 1 equal to 0 and x plus 2 equal to 0. Solving these, x equals 1, x equals negative 2. So what's my multiplicity for x equals 1? Well, it came from this factor, x minus 1 had a square on it, so its multiplicity is 2. 2 is even or odd? Even. So that means it is going to what? My x-axis. It is going to touch my x-axis. X equals -2. What's its multiplicity? Well, there's only one, so its multiplicity is 1, which is odd. And odd means what to my odd does what to my x-axis? Odd means crosses my x-axis. Next, we find our y-intercept. The y-intercept is at, or we set x equal to 0 to find our y-intercept. Sorry you can't see it, but we're going to just plug 0 into my function for all my x's. F of 0 equals -2. 0 minus 1 squared times 0 plus 2. So that's -2 times -1 squared times 2, which is -2 times 1 times 2, which equals it equals -4. But remember, my y-intercept has to be in what format? It's got to be an ordered pair, so the y-intercept is 0, -4. Okay, now we can put this together and graph it. So we start off with our points that we have. So the points we have are our x-intercepts up here, which are 1 and -2. So 1, -2. And then we have our y-intercept down here, which is 0, -4. Next we do our end behavior. So based off my end behavior all the way back up here, I know that at my last point, okay, where I cross the x-axis, it doesn't ever change directions again, so it's just going to keep going down. For this end behavior, again, this is the last point on the left where it touches the x-axis. So it's just going to keep going in that same direction, which from our end behavior we know is up. Now we fill in the middle with our multiplicity information. So let's look at this multiplicity of this 0 first. So this was my x equals -2. It had a multiplicity of 1. So that means it's odd, so it crosses the x-axis. Okay, I'm not going to keep drawing for a minute. I'm going to make a point in a minute. So I'm just going to draw it. I know it crosses like that.